welcome to your lesson on recognizing transformations for quadratics. Here's an opening question for you. For which quadratic function is describing the transformations easy? For which is it tougher? For example, let's say we began with a basic quadratic like this, and then we have these two transformed versions. Which of these two transformed versions, when you look at it, is it easier for you to describe the transformations? And why? Okay, let's take a look at some discussion around that. So we had a basic quadratic, we created these two through transformations. This one is in standard form. It is tough to see the transformations in standard form. This one here is in vertex form. It's easy to see the transformations. Vertex form, we can clearly see what happened to x, we can see what happened to y here. Translation, translation, and here's a dilation. So whenever working with quadratics, we want to somehow get them into vertex form because then we can more easily talk about the transformations. So what could we do to make the transformations more obvious in the tough one? Well, we could change the standard form one, this one, into vertex form, and then we can more easily see the transformations. We learned a process of changing quadratics from standard to vertex form. Let's remind ourselves about that process now. That process is called completing the square. Do you remember it? So let's try with this one. So for this first part of the video here, just observe. You can take notes if you want, but this is not on the notes page that was provided to you. Okay, so first we begin by moving the constant term to the y side here. We're left with just the x things here. All right, now if you remember, we look at this, and if there's if there's a 1 in front of the x squared, we can proceed by doing b over 2 squared, and that is the process of completing the square. So we're going to do this value divided by 2 squared. That's 14 over 2 squared, which is 49. So we're going to add 49 to both sides. By doing that, we have created a perfect squared trinomial here, which factors very easily into this. This one here, this x squared, x, this 49, 7, and we have x plus 7 squared. And then over on this side, to maintain balance, we added 49 on both sides. So here we have 55, we're going to move that 55 back over here, and now we have vertex form. So now if somebody asked you what transformations took place here, we can clearly see a translation on the x and the y axes. So there was a horizontal translation, left, even though this says plus, we went left 7 units, and then a vertical translation down 55. If we looked at the original standard, you would not be able to say what that transformation was, but here we can see it. Let's try another one here. So this is another example of completing the square. This time we do have something other than 1 in front of the x squared, so the process is going to have a little bit more to it. Okay, again, move the 11 over. Now, since we have something other than 1 in front of x squared, we're going to factor that. So we're going to factor a -1 from both of these. So here I took that negative out here, put parentheses in. This is x squared. This has to turn into negative 18x because if you multiplied back, you would be back at positive. So here I factored that out. Now I'm going to do b over 2 squared. b over 2 squared, so this value divided by 2 squared. Okay, that divided by 2 is 9 squared, 81. Sorry, -9, but you square that's positive 81. So we're going to add 81 here to make this a perfect square. But on this side, are we going to add 81? Do you remember? Well, if we're adding 81 here, we actually have to subtract 81 here. The reason is, if we're adding 81 on this side, but then we multiply everything here by this negative, this is actually a negative 81 we've put on this side, so we put a -81 on this side as well. Those two combine to make negative 92. This is now a perfect square. X here is 81. 9, since we have a negative, and that negative remains in front. We've factored that into this. Now we move the 92 over, we have vertex form. From this vertex form, what are the transformations that took place? Well, we can see there was a horizontal translation, right 9 units, then a reflection here over the x-axis, and then a vertical translation up 92 units. Okay, so we have 3 now, and they go in this order, this, and then this last. Again, from the standard form, we would not be able to recognize those transformations, but here we can see them clearly. One last one to remind us about completing the square. Here we go. Move the 7 over first. Looking at this is not a 1, so we're going to factor it out. Here's 4 factored out. So this has been divided by 4, so has this. turns into a 6. Now we can do b over 2 squared for this. 6 over 2 squared is 9. We're going to add 9 inside here to create a perfect square. But if we're adding 9 here, what are we adding here? Well, if that's a 9, this is a 36, because this is not really a 9. Once we multiply by 4, it's a 36. Since we've added 36 here, we add 36 here. Okay, that gives us 43. This is a perfect square which factors into x plus 3 squared. Now move the 43 over, we have vertex form. In that vertex form, we can clearly see transformations. What are they? Okay, in this order, horizontal translation, left 3 units, then a vertical dilation, scale factor 4, and then a vertical translation down 43. Okay, so now let's take notes on the notes page that was given to you for this video. And you're going to try the same process. So you have a standard form, you're going to change it to vertex form, then describe the transformations that took place. Try it out here. Okay, so our goal again is, imagine you have a regular parabola parent function and g of x is the one given to us. You're trying to say g of x is what has been done to f of x to create this g of x function. Okay, here's that. Move the 16. This, when you do b over 2 squared, 8 over 2, 4 squared, 16, add 16 here, and then add 16 here. It's coincidental that we have a negative 16 and 16 here, right? That's because we began with 16 there. Okay, that becomes this. Actually, that tells us, since we have no value after, that this in the beginning was a perfect square. So this one here, we could have, without completing the square, we could have just looked at it and said, oh, it's a perfect square trinomial. That factors into this. So we could have done that, of course. Anyway, we have our g of x function. Now we can say g of x is this change, x plus 4 made to the basic parabola function. Okay, so what transformations is that? Horizontal translation left 4 units. Okay, try this next one here, and here be careful. Remember, we have a 2 in front of x squared, so you're going to have to factor that out. Okay, let's check. So again, how are we turning f of x into g of x? That's our question. G of x is the result of what change is made to f of x. Okay, there's our function. Move the 9 over, have this, factor out the 2 here. b over 2 squared for this is a 9, but 2 times 9 is 18, so we add 18 on this side. We end up with this vertex form function. That perfect square became this. This was 9 and was moved over here. Okay, so what are the transformations? Well, g of x is created by doing this to f of x. So again, we're taking this and looking at it in terms of f of x. We've been doing this for a while. So we see a 2 in front of the function. We see that x is replaced by x minus 3 here. And we see 9 is subtracted from the entire function here. What are the transformations? Horizontal translation, right 3. Vertical dilation, scale factor 2. And vertical translation, down 9. Great, try this one. Again, we are looking at how was g of x created from f of x. G of x from f of x. Okay, here's that. Move the 1 over. Factor out the negative 0.5, so divide both of these by negative 0.5. When you divide negative 4 by negative 0.5, it's a positive 8. Okay, b over 2 squared for that, 16. So we're not adding 16 on this side, we're multiplying 16 by negative 0.5, so it's a negative 8. Okay, that becomes this vertex form equation. This perfect square became x plus 4, that negative 9 moved over to be 9 here. Here we have it. Okay. That means g of x was changed in these ways. Sorry, f of x was changed in these ways to become g of x. We have a negative 0.5 in multiplying the whole function. We have an x plus 4 substituted for x. And we have a 9 added to the entire function here. Okay, what are those transformations? Horizontal translation, left 4. Vertical dilation, scale factor 0.5. We also have a reflection over the x-axis here. And finally, vertical translation up 9 units. Awesome. How about this one? How would you do one like this? You're given f of x in standard form and g of x in standard form as well. So now when we're saying change f of x to g of x, we're not saying we're going to begin with just x squared. we're going to begin with a transformed function already and transform it further. So you might have to do completing the square twice to compare the two to each other. Let's see how you do with this. Okay, there's f of x. I'm doing completing the square. Move the 4. B over 2 squared gives 4. We add 4 to both sides. This factors into this. These cancel. Oh, this was a perfect square to begin with. So you could have looked at that, said perfect square, done. Okay, that's f of x. Now we're going to do the same thing for g of x and then compare the two. There's g of x. Move the 9. B over 2 squared gives a 9 here. We're going to add 9 here also. Oh, look at that. This is also a perfect square. We can see, since this cancels out, this is a perfect square, which could have factored in the beginning to this. Anyway, we have f of x now, g of x, and your goal is to say, how was f of x turned into g of x? So what was that transformation? Well, g of x occurs when we do f of x, but we replace this x with x minus 5. Imagine putting x minus 5 in here. Then you end up with minus 5 plus 2. And that gives us the negative 3. Basically, what happens to 2 to turn it to negative 3? We have to subtract 5. So there's the transformation. That is, oh, it shows it here. See, we put that x minus 5 in here. If you add 2, you get to the g of x function. What transformation is that? Well, therefore, f of x is translated 5 units right. 5 units right to create g of x. Okay, one last one. Same kind of problem. We have two standard form. You have to complete the square on both and then describe what transformations took place. Let's see if you can do this one from beginning to end. Okay, there's f of x. By completing the square, you should get this function here. Check your work. Here's g of x. By completing the square, you should get this function here. Now compare these two. How does this one turn into this one? Well, to create g of x, we had to, this negative 1 to become a 3, we had to add 4. So x plus 4 is the substitution here. And this negative 4 to become a negative 5, we have to subtract 1. So g of x, here the change is applied to f of x. So I took the f of x, I substituted x plus 4 into this x right here, and I subtracted 1 from the entire function here. And that gives us g of x to confirm. What transformations are those? Well, you can describe those. This is a horizontal translation left 4 units and vertical translation down 1 unit. Okay, final 3 on your paper. Give those a try. Make sure you feel proficient with this process, and we'll see you soon. Great job.